Okay, good afternoon, everyone. Thank you, Dr. Day, and thank you, every participants. Thank you all. My name is Richard Zhu. It's my honor to be here to give you a talk about offshore wind energy development in China. So today I'm going to give this talk from these 4 points. First of all, I will give you a brief introduction by myself. Well, as Dr. Day just mentioned, I got my bachelor's and master's from Dalian University of Technology. After that, I got my doctor's degree in University of Akron in the United States. After my doctor's, I started to work for American Bureau of Shipping, which is a company focusing on ships and offshore structures, which is one of the largest third-party consulting company in the world. I worked in Houston, starting from an engineer. 4 years later, I worked as a manager for offshore engineering department. In 2001, I left ABS and joined China company called China Yangjiang Power. Started from, I created the offshore wind department in this company. I worked as a vice president, also a ship scientist. But luckily, this company grew from zero to today. In 2019, Yangjiang Wind Power was listed in Shanghai Stock Exchange market. Today's value is around 60 billion RMB. After that, in February of 2019, I joined Zhejiang University as a professor. So right now, I work in the Ocean College of Zhejiang University. Meantime, I am in charge of 2 research institutes. One is called South China Industrial Technology Research Institute of Zhejiang University, which is located in Guangdong City. The second one is a state lab, which is Guangdong State Lab, located in Guangdong, Yangjiang, which is a city. Yeah, as I just mentioned, right now I'm in charge of the South China Industrial Technology Research Institute of Zhejiang University. Actually, this is a research institute. We focus on the technology and the research achievements to transfer into companies. So far, this research institute has incubated almost over more than 30 companies and generated revenue over 1 billion. Meantime, we got government supported research funding for 59 million RMB. Also, we work with the companies. So far, we have won about 73 million RMB from the company research funding. Also, I'm in charge of the Yangjiang Offshore Wind Energy Laboratory, which is a laboratory, actually is a state laboratory. Some of you might know, actually, in mainland China right now, different states are setting up their called state laboratory. So right now, I'm in charge of the energy laboratory, energy state laboratory in Guangdong, focusing exactly on offshore wind energy. So far, we have got supported around 150 million RMB research funding, and we're focusing on a couple of topics for the research in offshore wind. Well, if any one of you have any question, you may raise up or just talk to me in the I'm sure if in the video we can talk to the students.
Yeah, do it. Type in the question in chat window, so no worry.
Mouse doesn't work there. Okay. Second part, I'm going to talk about the global offshore wind development, the situation for the global offshore wind. Well, currently we see offshore wind is not only a supplement to traditional energy sources, but also which is going to be a replacement. Three main reasons. One of the reasons is the unit per wind turbine, the size is getting larger and larger. So the capacity right now for commercial use, the maximum is about 15 megawatt per unit, which means for one offshore wind turbine, the electricity which generates is about for 100,000 square meters of solar power. The second reason is the quite large size for the wind farm. Currently, well, to be developed or some underdeveloping in mainland China, each unit of the wind farm size is about 0.5 to 1 gigawatt, so which is quite large. Some of you must know we have nuclear power in Guangdong area, especially Daya Bay nuclear power station or Dayang nuclear power station. Well, this nuclear power station supplies almost 25% of the total electricity of Hong Kong, which means 80% of the electricity generated from Daya Bay nuclear power has been sent to Hong Kong. Well, for that nuclear power station, the total size is 2 gigawatt, currently, which is about the same as 2 offshore wind farm sizes. But the third reason is the cost of electricity keeps dropping down. Currently, in today, the electricity of offshore wind electricity, which is much lower than fossil energy. In the future, we believe the cost of offshore wind farm electricity is going to be cheaper and cheaper. All of these reasons, which make the offshore wind farm is developing very fast. Offshore wind, which actually, if we look at the history, we should pay attention to a couple of countries like Denmark, UK, Germany, and Norway, also currently China. Actually, offshore wind started in Denmark, but it has been rapidly developed in United Kingdom. I would say for the technology is scientifically advanced in Germany. Meantime, Norway is a small country, but Norwegian companies have supported quite a lot technologies to offshore wind areas, especially offshore engineering and technologies. Meantime, Norway is a country who doesn't develop a lot of offshore wind farm in their country, but they are leading developers, one of the leading developers, a Nordic region. Well, I would say for the cost reduced, but Chinese market makes the cost of offshore wind farm getting cheaper and cheaper. So that's a situation. Currently, for the Europe, starting from Norway till south, all the countries are developing offshore wind farms. Well, if you look at the offshore wind farms cost, we call LCOE, which is called levelized cost of electricity. From this number, you can see we call it levelized, which is actually averaged the cost for generate per kilowatt hour for the electricity. In 2014, the cost is about 1.56 RMB per kilowatt hour. 3 years later, the cost dropped to 0.79 RMB per kilowatt hour. And 2 years ago, the cost dropped to 0.57. Today, we see in 2023 and the future, currently, the LCOE in China is about 0.34. Germany 0.38, UK 0.35, USA 0.46 RMB per kilowatt hour. If you look at this number, which usually we compare with the fossil energy cost in China, for the coal generated electricity, the cost is about 0.4 RMB per kilowatt hour. So comparing these numbers, what we can tell the cost for offshore wind farm is getting cheaper and cheaper in the future. Well, we believe offshore wind farms there are more and more offshore wind farms going to be constructed. If we look at the US, I would say US has very good wind conditions. Well, if you look at these numbers, the red one, which tells us the average wind speed, which is about 9 to 10 meters per second, well, which is, we call this is the best wind quality. In most area of China, our average wind speed is about 7 to 9. Actually, which is much lower than the wind speed in USA and Nordic regions. So United States has a very good offshore wind resources. Besides, on the west, US, the mainland is facing Pacific Sea. On the east is facing Atlantic Sea. Meantime, in the north part of the United States, there are Great Lake regions, which could be which could develop offshore wind farms in the future, also in the south, that facing Gulf of Mexico. Well, I would say in the future, there's going to be a lot of offshore wind farms to be constructed in the United States. Also, right now in Asian countries, except for China, if you look at Japan, India, South Korea, Vietnam, Thailand, and the Philippines, all these countries are designing, or some of them even constructing offshore wind farms. If we look at the general number, we see global offshore wind installed. By the end of last year, the cumulative installed capacity of offshore wind power has reached 64 gigawatt, which is quite a lot, which will create about 15% increase compared to the year of 2021. So from these numbers, we can tell every year the offshore wind farm, well, a lot of offshore wind farms have been constructed, or a lot of them under construction. Also, we can tell by the end of 2022, by the end of last year, the cumulative offshore wind power installed accounts for around 7% of the total global wind power installed capacity. Well, this This picture tells us, well, first of all, China has contributed a lot for the global offshore wind farm capacity. China has constructed around 50%, which is 30 gigawatt. I would say in past around 5 to 6 years, which is half of the total capacity of the world, especially in 2021. But there's a big increase. We can see 2 years ago, which is 2021, there's an increase of 21 gigawatt to the total offshore wind capacity, actually, which is contributed from China. But there's because of policy, if you know, in mainland China, we has a different electricity policy. By the end of 2021, the electricity, the grid price for the electricity generated from offshore wind, which is 85 cents per kilowatt hour. After that, which in the beginning from the beginning of 2022, the price dropped around 40 to 50%. So that's why in 2021, so much offshore wind farm capacity has been added, which is around 20 gigawatt. Yeah, for the geographical portion, we can see, which is for China, till by today, China has around 50% of the offshore wind farms comparing to the global offshore wind farm capacity. Also, comparing with the new installations, offshore China has contributed 58%. But talking about the market size, so based on the data right now, which is globally, there is 130 gigawatt of offshore wind capacity to be added. But the number is between this year, well, which is the next 5 years. I'm not sure if this number is accurate or not, but this is number reported by many countries, which is 130 gigawatt to be added in the next 5 years. Based on the today's investment cost, to have this 130 gigawatt offshore wind farm constructed, the total investment is around 20 billion RMB, which is quite a big market. Also, in the future, for the operation and maintenance of this size offshore wind farm, we still need about 50% of the initial investment cost, which is 10 billion RMB in the future for this size offshore wind farm operation and maintenance. Okay, let's talk about the offshore wind farm, the challenges for offshore wind farm in China. I would like to share this table with you about the energy structure of China currently. If we look at this table, well, currently the traditional fossil fuels still contributes around 51% of the total energy for China. The traditional coal was still the main electricity, generates main electricity, which is 45%. For the clean energy or renewable, well, clean energy like nuclear power contributes about 2%, hydropower 16%, solar power in China is about 16%, onshore wind is about 13%. Offshore wind currently for the whole electricity network is only about 1.2%. So, well, I have discussed with some of the people from the government department who make decisions about energy. They told me in the future, especially in Guangdong area for the electricity network, 30 to 35% of the total electricity will come from offshore wind. So then we can see there's a very big increase in next hours 10 to 15 years in mainland China. These pictures roughly show you the size for offshore wind turbines. Well, some of you might know the Guangdong Tower. The total size for Guangdong Tower, the height, is about 450 meters. For the 6 megawatt wind turbine, which has been installed quite a lot in past 5 to 6 years, basically, before 2021, most of the wind turbine installed with a maximum size around 6 to 7 megawatt. So the total height is about 425 meters. And currently, this year and next year, most of the wind turbines, offshore wind turbines, to be installed with a size around 10 to 15 megawatt, which is, if for the 15 megawatt offshore wind turbine, the total height for the wind turbine is about 525 meters. Well, this is the size of offshore wind turbine, the cost. For each unit, right now you see for 6 megawatt, the total cost is about 100 million RMB for each cost. So now nowadays for 15 megawatt, well, the total cost is about, I would say, is about 1.6 to 1.8. No, 180 million RMB per unit. Also, for the total cost, the wind turbines itself accounts for around 25% for the total cost. The supporting structures, the steel structures itself, also the installation, the cabling, all of these accounts for about 45% for the total cost. So that's why for the offshore wind, there's 2 groups of people, well, basically in this area. Some people with a background of mechanical and electronic background, some of them with a structure background. So basically right now, I would say the main problem or the most difficult problem for offshore wind turbine to be developed, well, which is the engineering and the technology, which is how to save the weightage of the supporting structures, how to make the installation easier and easier. So this is a challenge right now. Roughly for a wind turbine like this 15 megawatt, the total steel structures required is about 30,000 tons, which is quite a lot. 30,000 tons per ton, the cost of construction is about 15,000 RMB per ton. So for each foundation, the steel cost is about, well, I would say, is about 40 million RMB per unit just for the steel structures. So if we can save the weightage like 10%, which is going to save the cost quite a lot. Well, currently we would say for the challenges for China offshore wind is still the shortage of engineering technologies, also the right engineering equipment, and of course professional talents. Well, for the past, China started to develop offshore wind farms from 2008. But that time, actually only 1 or 2 very small sized offshore wind farm to be tested or just to be constructed in Shanghai and Jiangsu area until 2016. Not so many offshore wind turbines got installed until from 2016 till last year. I would say in past 5 to 6 years, most of the offshore wind farms were constructed during that period. So in this area, we don't have much research or study, especially for the engineers and well, the professionals. So that's why I would say the challenges for China offshore wind farm are the technologies, equipments, also right people, talented people. For the whole structure of offshore wind farm, a lightweight and reasonable supporting structure design is very important. In this area, a lot of developers right now, they think the most difficult thing is to how to save the supporting structure, try to save the weightage, not only because of the cost of the supporting structure itself, also because of the installation. If the weightage getting higher, it's very difficult, or it's going to be very expensive to have them installed. Like this foundation we call a monopile. Right now, the largest size for the monopile, for one unit, one pile, the weightage is about 2,500 tons. If you can use like 1,500 tons supporting structure, not only you can save the steel cost, but also you can find more installation vessels for this installation. If the weightage goes up to 3,000 in the future, it's going to be very difficult to find this installation vessel as well as the impact hammers. It's going to be very difficult to find big hammers to have this pipe out to the ground. So that's why I believe as for the structure design is quite important right now for the offshore wind farm, offshore wind. Yeah, as I just mentioned, well, what are the challenges for China offshore wind development? I will say, well, basically that's engineering and technologies. There's main 5 areas I'm going to briefly introduce to you one by one. First of all, we call accurate and reasonable soil investigation. But for every wind farm to be constructed or to be designed, first of all, what we need to do is to investigate the foundation, especially the soil conditions. After we get this data, then we're going to design the foundation. But currently, the big challenge is, well, I will say I have got involved over around 20 offshore wind farms. I have been consulted or designed 20 offshore wind farms, the foundations in the past 10 years for Chinese market. Most of the foundation we call over-designed, which actually proved to be is quite over-designed, or sometimes over-designed 50%, even 60%, just because we can now get the very accurate and detailed soil condition. Well, the background is this is quite complicated, not only because of the investigating people or the equipment. Also, it's really affected by the construction procedure for the offshore wind in China. So to get an accurate soil condition is quite difficult. There's a lot of work need to be done for the soil investigation for the offshore wind farm development. The second challenge is the supporting structure, we call the innovation and optimization for the offshore wind turbine supporting structures. But currently, you can see there are 5 different foundations, which these 5 different types are the most widely used foundations for offshore wind farm. first of all, we call this monopile. This is jacket foundation, this is tripile, this tripod, this is tripile, this is suction jacket foundations. Well, each of the foundations has different characters or different advantages, really depending on what kind of the size of wind turbine, the soil condition, the wave height, also depending on the installation equipment. But I would like to give you one example. I got involved a little bit for this project, this is the first offshore wind farm in Germany, which planned in 2003, started in 2006, which is the first real offshore wind farm developed in Germany, which is 400 megawatt. The name of this offshore wind farm called BOR. But it's very interesting, the background for BOR, which actually started from a company in Denmark, which is a turbine manufacturer. Some of you might know this is a very old brand name for the wind turbines, but nowadays it's already gone. The company does not exist. Well, anyway, that's first offshore wind farm BOR, which is 400 megawatt with 280 wind turbines to be constructed in Germany. But this offshore wind farm is supposed to be finished the construction and get grid connection by the end of 2012. So in 2013, well, I went to visit my friends there, and I was told to see in the back of the picture, there's still 12 offshore wind turbines haven't been installed. So the whole project has been delayed for around 3 years. But the delay of construction of this offshore wind farm, which causes the cost of a lot of waste of cost. Also, during construction of this wind farm, actually this company went bankrupt. Also, a big disaster happened when people got killed during construction of this offshore wind farm. So this is one of the failure. Well, because this is a failure example in the offshore wind farm history, which is actually which is a failure example, failure lesson to the whole area in Europe. But the main reason for this wind farm, why it's been delayed for 3 years, and the cost, the cost, they have spent around 500 million euros more than the budget. So, well, the main reason is because of the design of the foundation. Well, this is a tripile foundation, which like about 5 to 8 years ago, which is very popular in mainland China. A lot of people use this wind farm as an example, try to promote the tripile foundations in China. But at that time, I just started to, well, I'm one of the pioneers working in mainland China offshore wind farms. I refused this to use the tripile foundation just because I don't think this is a good design as a support structure, because this kind of foundation, they has the disadvantages of monopiles and jackets. Well, it turned out to be is actually the design is really a disaster for this wind farm. After that, this kind of foundations have never been used anymore, no matter in Europe or in China. nobody has used these foundations anymore, just because actually this is a really disaster design. Another example is about phone bank. Well, my group, my team has got involved in this project. Actually, we got a design of some of the foundations, but which is 300 megawatt. 300 megawatt in Belgium. The construction started in 2011. I was at that time, which is the largest offshore wind farm in Belgium. And the foundation was designed by a very big engineering company from Denmark. They designed to use 48 concrete. From this picture, as you can see, the 48 concrete foundations for this offshore wind farm. Each foundation, the weightage of each foundation is about 4,000 tons. By transferring this foundation onto the side, in the future, after the foundation set onto the side, they're going to put a set inside, because currently you see for this foundation is hollow inside. They're going to put around another 2,000 tons of sand into this foundation, make it very heavy, very stable. They only built 6 foundations. The developer has stopped this project for quite a long time because it's a very, very time consuming. In Belgium, not like in mainland China, for the concrete structures, actually, which is very time consuming. Also the move, the transformation for the foundation is very difficult. For the 300-500 tons, about 4,000 tons, you have to use a very big lifting vessel, like a lifting boat, to transfer these foundations. This is a 5,000 tons lifting vessel, lift boat, which is very, very expensive. So based on the original design, if they use all the concrete foundations, it's going to be another disaster for this project. Then later on, our team provided the steel structure design for the remaining around 42 foundations. By using this design, the total weightage for the concrete foundation, which is about 4,000 tons, by using the steel foundation, the average tons about 500 tons. So which saves, well, first of all, which saves a lot of the weightage, which makes the installation, transportation, and installation quite easier. Also makes the efficiency. Well, we have all the steel structures constructed in the shipyard. One by one, they transfer onto the site and have them installed. So finally, for the whole project, they use 6 concrete foundations and 42 steel structures, which is designed by our team, including the substation with the 2 steel structures. But after that, actually, in the past about 10 years, I travel to Europe quite often, also bring my Chinese friends to visit this offshore wind farm. For number 3, I think for the challenges for the offshore wind farm is about the installation equipment and technologies. As I just mentioned, only in the past 6 years, China has built about 30 gigawatt offshore wind farms. Actually, originally we don't have a lot of installation and other equipment, because for the offshore wind farm, especially the installation vessels, we have to be customized, designed, and manufactured. So this is called a self-elevating installation vessel. Well, I'm very proud to see that the first one in China, I designed the first installation vessel in China, which is the first one in China for 800 tons lifting capacity. And this is the second one in China, built by a Jiangsu company, but this is for the whole design which is designed by European companies. And this is the third one in China. I designed the third one in China also. I invested by myself. But total investment at that time is about 350 million RMB. So this is the third one in China. Meantime, for all other like impact vibro hammers, this drilling equipment. So in this offshore wind farm, in this area, we need a lot of specific tools or equipment. Like for the vibration hammers, by using this hammer, we can have the monopiles being installed. Well, this is something about our group. What we have done is we have done quite a lot we call rock socket pipe, because in some part of China, especially like the Fujian area or Guangdong area, or currently like Hainan area, on the ground, actually it's not soil, it's rocky, it's rock. So in this situation, we have to make a hole in the rock. But most of the rock with the strength about 100 megapascal is quite strong. So we make a holes. Right now that we drill a hole about with a diameter for 10 meters, with a depth for 20 to 30 meters. Then put this monopile inside the hole. After doing that, we use grouting materials. Actually, Professor Day were quite familiar with this area. We use grouting material to have these monopiles, and the rock foundations will have them glued together. So we have done around 90% for this technology and foundations in China. So we're quite proud about the large diameter rock socket pipe grouting technology in China. And also we have built the grouting machine by ourselves. The equipment we developed by ourselves. Meantime, we're developing the grouting materials, and the maximum strength can go up to 140 megapascal. Also, this is we call cable protection system, which is used to protect the cable from the foundation till the sea, because for the electricity transformation, we have to use cable, and the cable partially has to be installed into the foundations, partially has to be buried into the sand, into the foundation. So there's around 10 to 50 meters is very easily to get damaged. So we have invented this equipment we call cable protection. We call cable protection system, which is quite unique in this area. The first one has been installed for over 7 years. None of them has got damaged. So we have quite a good reputation in Chinese market. And for the number 4, number 4 challenge, I would say that's called the electricity transmission. Well, right now, they could actually DC high voltage at direct electricity transmission. Well, this is a quite new area in China, I would say. So far, only 2 of these platforms has been constructed. Each cost is about 10 billion RMB, quite very, very expensive just for this substation. You can see the size, quite a big size. In the future, I believe there's quite a lot of this structure going to be constructed. At least 50 to 100 of this substation is going to be built in China. So for the substations, not only related to electricity knowledge, but also quite related to offshore engineering technologies. But the number 5 challenge is for the operation and maintenance. Well, in the past 6 years, so many turbines have been installed in the sea. And some of them do have some quality problem or quality issues. nowadays, the developers realize it's going to be very difficult, too difficult to have the maintenance in the sea. It's not only because of the technology, but also because how to get onto the wind turbines, which is depending on the weather, on the wave. And sometimes if you want to change the blade in the sea, it's quite difficult and very, very cost consuming. Well, for the last part, I'm going to still need about 2 to 3 minutes to finish my talk to briefly talk about my research topics. I'm looking forward to the cooperation with professors and maybe the students in the future for our group. Well, first of all, we do blade design and testing. We have built the largest testing platforms in China, but I would say in the Asia, we have the largest blade testing platforms in Asia countries, which is located in Yangjiang to the coast. We have 5 testing platforms. The total cost is about 150 million RMB. Is already finished for these platforms. The second topic, we do safety study. Also, we do safety training. This is our training center. Is located in Guangdong area, exactly in Yangjiang city. For the pilot equipment, well, this is one of our research topics. We do the impact hammers and vibrate hammers. So impact hammers, well, we studied it just because the size getting larger and larger. The largest impact hammers using right now is only for offshore wind. The impact hammers traditionally has been used quite a lot for the foundations for the buildings, but nowadays the largest one has been applied to offshore wind foundations. So far, the largest one is always about 4,005 kilojoule. But right now we are developing one with 6,000 with some Chinese companies. Meantime, for the vibrate hammer, which is quite a new technology, which I would say in mainland China, there's none of the companies can build this kind of size vibrate hammer. These pictures are from a company from Holland, but we are still studying this, try to have them built in China for the vibrate hammer. Also, just as mentioned, for the large diameter rock socket pile drilling, we do drilling and grouting technology. Well, we are quite good at grouting technology and equipment, but for the drilling, which is quite new actually, we are still doing this research because for the pool we need to is quite with big size. Right now we are looking for the drilling one time with the drilling go up to the diameter up to 15 meters. So this is quite difficult. Also, it's under the water. You have to make this machine work quite stable. For the supporting structures, well, this all the time. We're still looking, we're still studying and looking for the innovative supporting structures. Try to save the supporting structure cost. Also try to make the installation of the foundations more and more efficient. For different kinds of installation equipment and tools, as I just mentioned, for the jackups, well, so far I have designed 3 jackups by myself in China, and for the vessel, for the transfer, people transfer vessels. Also, for this vessel is designed for extreme weather, like during winter, the wind speed is quite high, small boats cannot go onto the sea. We use a big boat. So different tools, like the hammers, this is drilling, this is This is the drilling machine. This is like an arm used for the monopile installation. As I just mentioned, for the self-elevated installation platform for checkups, which is this is the real one with new technology in China, actually, which is started building in 2015. My group designed this also. I invested this at that time. 350 million is quite a lot of money for us. It's the history. Also, we are doing research about the implication of unmanned vessels in offshore wind. We do subsea structure survey. But basically, because the grouting happens quite a lot. Well, this is a very hot topic right now. Well, we should pay a lot of attention to the skull protection. A lot of foundations, this damaged by those because of scoring. Well, these two pictures show the real wind turbines in Jiangsu Rudong area. You can see the sand because of scoring around, which is around 10,000 cubic meters sand has been taken away. So the developer has spent another about 15 million RMB per foundation just for the scope protection, and which cannot guarantee, which cannot be guaranteed to last for around 15 years. It's very difficult to see that. And also, the subsea structure for the cables. For the cabling, the cable is supposed to be buried under the sea for at least 2.5 meters. But from this survey, we can see actually the cable is on top of the ground. Well, by this situation, it's very easily to be damaged by small boats, actually, which happened quite a lot. The big disaster happened last year. Around 6 cables, 2 main cables and 4 small cables got damaged. The total cost, but total damage is it costs about 2 billion RMB happened last year. Yeah, also we do the underwater video and camera for other structures. For the scope protection system, we have developed our own KIP scope protection system. Meantime, we're doing small structure here is monitor, basically to monitor the vibration of the structures. Okay, thank you everyone.